Hi everyone, welcome to Cola Teaches Math. So the next set of videos I want to do is on the different types of tests for convergence and divergence. And the first one I want to start with is the geometric series test. So let's just quickly go over the conditions. So a geometric series is anything that looks in the form of a r to the n or summation a r to the n minus 1. So the index is going to be different depending on what form it is, but you're just basically looking for a series that has a pattern. So A is the first term of the series, and R is the common ratio, so it's what we're multiplying by to go from one term to the next. And a geometric series is one of the only few series that we can figure out what it converges to, not necessarily just it converges, but it converges to the sum, which is A over 1 minus R. So I'll show you a few of those. And the conditions are if the absolute value of R is less than 1, we're going to converge. And if the absolute value of R is greater than or equal to 1, we're going to diverge. So I have this worksheet right here. I'll post the entire answer key, but I'm just going to do a few of them and skip around. And if you're struggling to figure out what R is, my suggestion to you is to write out a few of the first terms. So like, let's look at this first series. If n is 1, then the first term of the series would be 1/2, plus when n is 2, it would be 1 over 2 squared, n is 3, and so forth. So that you can say R, you can see that R is going to be 1/2. We're multiplying by 1/2 to go from one term to the next. So then you're going to say, okay, the absolute value of R is 1/2, which is less than 1, so we're going to converge by the geometric series test. Okay, I don't think I need to write that out every time. So like that, this is what I mean. If you look at example 2, replace n with 1. Okay, so that's going to be 3 squared over 4. Then replace n with 2. Let's move this down a little bit. If we replace n with 2, it's going to be 3 cubed over 4 squared, and with 3 to the 4th over 4 cubed, and so forth. So you can see that the pattern we're multiplying by, R, is going to be 3/4. So the absolute value of R is 3/4, excuse me, which is going to be less than 1. So we're going to converge by the converge by the geometric series test. The next one I want to do is number 4. So if we replace, first thing I would do is rewrite it. I wouldn't actually. Let's replace n with 1. So we're going to have e over pi plus, actually I lied. Just kidding. I would actually rewrite this first as e to the n over pi to the n. I think that's going to help you guys see. So it's going to be e over pi plus n is 2, e squared over pi squared. N is 3, e cubed over pi cubed. So you can see that we're multiplying by e over pi. So the absolute value of R is e over pi. That is less than 1, so we're going to converge. And this is an interesting one if you wanted to find the sum. So the first term is e over pi over 1 minus r, e over pi. So I would get a common denominator for the bottom. You could do it however you want to do it. So the bottom is going to become pi minus e over pi. The top is e over pi. We're going to keep, change, flip. And then you can see this would be the sum, and that's what we would converge to. Done.